I will, why don't you remind me later. Okay. So this one suggested find the required package at this link. So here's Seaborn. All right, he's downloaded. And then we'll do a pip uninstall Seaborn. I did start the recording out. Yes. All right, so I'm going to install that wheel I just downloaded. Okay, it says it was successful. Okay, same error. All right, so that means that wasn't a fix. Okay, so this is actually saying the issue is with Sippy. So let's try. I'm going to uninstall SciPy and that. Then I'm going to say pip install Seaborn. And that's reinstalling SciPy. Well, it feels like it's doing something amazing.
That Windows command line has any differences between Unix command line?
Is there differences? Well, yeah. I mean, there's substantial differences. I mean, they're not based on the same OS. So, like in Windows command line, you type in dir to see the list, and Linux is LS. I mean, it's a whole different OS.
Then for the install these packages, is there any differences?
Well, no, because this isn't necessarily related to the command line. This is related to Python. So pip is a program that's available for both Mac OS, Linux, and Windows. So installing these packages, these are pip Python packages.
So you can say keep running on different platforms, so they can be compiled differently,
Possibly.
but they're still doing the same thing.
Let's see. So we're getting this no module name, NumPy. Okay, this is a new message. This might be actually okay. Short answer, use Anaconda. Anaconda is like a package of data science based things wrapped around Python.
That's enough solution.
Okay, I'm going to, so I've already deviated from what I had put in Slack, so I'm going to actually back up, and I'm going to say pip uninstall numpy. Pip uninstall matplotlib. And we're going to install from my wheels only, not from all this stuff. So we're going to go back to the wheels that I gave you on Slack. So let's cd ccolon. All right, so we're going to say pip install. And we're going to start off by installing the SciPy. Let's get that guy working. Interesting that he wants to install NumPy as well. Okay. We'll see how that works. Because this is NumPy 1.173. pip uninstall SciPy. I'm going to uninstall it again. Install that. Then we're going to just install NumPy first for my wheel. Okay, so I have NumPy for my wheel installed. Now we're going to install CSC548 for my wheel. And it's just installing CSC548 because the NumPy is already there. Otherwise, that was downloading NumPy. So I want to make sure I'm using my exact wheels. Then I'm going to do pip install my matplotlib wheel. Okay. All right, so now I'm gonna install my Seaborn, but I'm not gonna use the wheel I downloaded because I believe Seaborn should be fine. So I'm gonna do pip install Seaborn. Okay, so that says it's installed. Okay, so now let's try our Python again here. Okay, so that did not fail. Did it? I don't even remember if my code does now. Oh, it put it in a vertical bar chart PNG file. So that's in documents. All right, here's my file. There's my chart. Ooh, what do I open it in? Photos? Paint?
Photo is fine. Pen is editing.
All right.
Okay. Now this is plotting. It should using the.
All right. Well, but so anyways, before we analyze what we have here, so using the 3 wheels I gave you in the right order, you install NumPy wheel first. That gets you the correct version of NumPy. Then you install the CSC548 wheel. Then you install matplotlib wheel. And from there, you can then freely install Seaborn normally, pip install Seaborn, and you have a functioning Seaborn environment. Does that make sense? So if you aren't sure which you installed from which, do what I just did, where you uninstall NumPy, uninstall CSC548, uninstall matplotlib, uninstall Seaborn. So you have none of them. Then install my NumPy wheel, CSC548 wheel, matplotlib wheel, then pip install Seaborn. And that should give you a functional platform for all the things.
Sorry, what is the order again?
NumPy wheel. So these are the files I put up on Slack. So NumPy, CSC548, SciPy, CSC548, whatever. Then matplotlib. And once you have that, then you can do a pip install Seaborn, not from a wheel, just normal, plain Jane, let it download Seaborn.
Okay.
All right. So what we have here is on our y-axis, we have our ratings, right? And what do we have here on our x-axis? What are these values?
I think it's just generated. Like, that's just the way that it works.
What did you put in here?
What is count?
So let's go look at the code.
Oh, count once. It appeared once.
So here's my top 7 rated by name. So I'm setting the index to name. Now, what I want to do here, because this is not something I've done before, I just want to undo that for a second. I'm going to run this again. And I want to see what I get. I think there's a way for me to just display that without...
Your Mac will automatically open it, but your Windows won't.
Really?
Yeah, your Mac will automatically.
That's the thing? Okay, so that did not change the... These are definitely our ratings.
But you didn't set your axis, right?
Well, I have Y to rating and...
Set your X will just automatically generate 0 to 1.
You cannot set both, it will yield to you, I remember.
Okay, well let's try it, then we'll look at the documentation. Make sure we're doing this right. All right, so you can't have it for both X and Y. Sounds reasonable enough. Now we probably do want to have, let's try X be the rating. Just see if at least those things are in the better order. Yeah, that's worse. So we'll have Y be
You can put serial name on the X.
but then where does rating come in? So X would just be name.
Run it. Let's see what's different.
Yeah, so that's actually worse. So we probably want to, even if we're doing the serial name, you want to have that on Y. And if you remember from the book, that is that for things that have long names, they get cut off. That's the whole point of having the 2 types. All right. Now, what's up with it cutting off over here on the left?
I don't know how to do.
Does everybody else get that too?
I find no way to changing that.
Yeah, whatever.
I think you can make the letter smaller.
Well, yeah, it just still is interesting that it still cuts it off. I mean, because the stuff is here. We can see that only a third of the E is there, but we can tell that it's there.
That was actually one of the reasons that decided that I would not make a graph for 7 things. Because all the
You should be
things that
able to change that.
Oh, change the size?
But I don't know. I cannot find anything.
Yeah. Well, we're going to call that the least of our worries for a second. Okay, so let me. All right, so here is. So the default here is count. So let's look at their example code here. So they've read in Titanic stuff. They set the style. They set the titles. Actually, we might be able to do it based on font size right here. So we'll come back to that in a second. So they're doing. All right, so here's the deal. It treats the, so in this case, their class. They're having their x-axis being class, so these are the various classes that are showing up. Their y-axis is automatically in numeric. Now, it's doing this off of count, though. What made it automatically choose count? Here's the data set. Oh, this is called a count plot. So this is actually a bad example that we're doing because we don't want count plots.
Then you can try data frame plot.
Let's see, it's also a count plot. Ah, here's a bar plot. This looks more like what I want. So, oh, I like this pastel thing. This does the stack chart, right? Yeah, so we don't need the 2 pieces, but let me just take this code and we will modify it because I think this is going to give us what we, well, at least better than what we have. Okay, so we're going to stick with the pastel codes, but we do not need the second chart because this is for that stacked thing where you have two charts together. Title is going to be serial rating. And let's just try making our font size 14. We'll see if that makes any big difference. We don't need a legend on here. All right, and we're gonna set our Y label. Oh, actually, we need to change this thing. So X is going, what did we decide X is gonna be? X is going to be the values, so the rating. And we'll spell it better. And Y is going to be the name. All right. And our data is going to be called top 7. Like that. I don't know what we'll see what that pops up as. Yeah, this is for the legend. We don't need that. I'm going to call this guy bar.png because we're not actually doing a stacked one. Okay. Let me come out here. Here's my bar. Ah, that looks better. So there's my extra fiber. Up in the 90s, Ani. See, it's. You just don't get it?
No, I don't get it. No.
Okay. So this seems like a reasonable enough way to visualize. I am still a little perturbed why the text is always cut off over here.
I also think about, could we change the picture, like the image size? But there's no way. I didn't really thought about it.
Well, let's find out. Matt, plot, lib, cutting off labels. Text chopped off. What, did something funny pop up?
Just, that's a good example. See how it's chopped off on both axes?
Oh, yeah. PLT tight layout. Let's see what that dude does. Okay. Ha!
Woo! Awesome. Wow. Okay. Stack Overflow for the W. When does that happen?
That's awesome.
All right. Perfect. All right, so that's our names, and that looks like a pretty good way to visualize that, right?
How do we make it a vertical one? I just want to see what it looks like.
Oh, that would just be switching the X and the Y.
Yeah, I was doing vertical too.
Yeah.
I'm
So
not gonna like the space.
there's the Y. There's the X. Oh, there's 2.
Yeah, that was why. So please consider.
Yeah, no, this is fine. This is good.
But can you?
Mr. Gonzalez can read that just fine.
Do you think we could make the writing like this?
The who?
The writing of the name there, like
Vertical?
Yeah,
Oh, I see. Yeah, I mean, the answer is probably.
probably. Okay.
Yeah, it shows. Yeah, I think that's what she's saying is have it do the angle looking things. Well, we're down the rabbit hole. Let's find out. Lib label orientation. Rotating custom tick labels. This is text in Python.
Ooh. Oh, that's cool.
Okay. So we want to rotate on the X. Probably not 90. We're probably going to do it like at 60 degrees. Because 90 would be straight up and down.
Mm-hmm.
Well, you're probably right, actually, but 60 is more correct than 90. We're going to see what we're dealing with there.
That's not bad. That looks pretty good, actually.
Wow.
'Cause especially since they're like such long names. Like,
Mm-hmm. There you go.
Well, I feel like I just suck at reading graphs. That's all.
I mean, I still think the original one we had made more sense. Like, even with all the fancy, angling and stuff here, I think the one that had the things going across and the labels on the Y, I think was easier to read.
Because I mean, like the all brand with extra fiber was a 90, like a 93, right? That looks like a 98, right?
Or aren't we now just arguing about how much it won by?
No, it looks dwarfed.
Yeah, I understand what you're saying.
Versus when you had it horizontal.
Well, keep in mind that there's 20 between here.
Right.
So that means 90 would be right here in the middle. So this really is, it looks like 93.
You can have a ruler to measure it.
Yeah.
I guess when you look at horizontally, there's no
how would
white
you
space
add
there.
more, like, to like instead of counting by like 20, like count by 10? How would you do
Well, let's find out. So we really want to change the scale on Y. Does that sound like the question I should be asking?
Yeah, could you do 10 ticks instead of just 5s?
Y scale? Oh, here, y-axis limit. Here, y limit. Okay, so we can do this 50 to 100.
Is that what we're looking for?
I think so.
Is there a Y max instead of a Y min?
Why 50 to 100?
Well, because I don't think any of them were lower than 50 in the top 7.
Oh, true.
And nothing was higher than 100. I'm not sure is that better? Well, he's different.
It works.
I like this.
I mean, maybe that looks more like 93.
Yeah.
I mean, that's probably fair.
So like, but if you wanted to add more like ticks in general, so like you still wanted like the limit from 50 to 100, but like let's say like you wanted 50, 55, 60, 65.
Yeah,
But
I get what
you
you're
could
saying.
Add like more ticks.
More ticks.
Could you say 10 to 100?
Oh, I see what you're saying. Like, I purposely expand it.
Yeah.
Well, my guess is the answer is yes. Just a matter of calling the right function call.
Oh,
Yeah,
alright.
so that looks like it's back to where we kind of were. So we actually
Added
can
100 to the top.
pop this at to 60. So I don't think any of them were below 60. I don't think that's going to actually change. It just might make it a little bit more obvious that it's a 93.
Whoa.
Hey, that did look fine.
That put more ticks in.
Yeah, so it looks like that you have a certain size to work with here that is driven by, because it's no matter what we've done, the size of this box has stayed the same.
Mm-hmm.
Yeah.
Yeah.
I mean, there's still gotta be a way though to like change like the scale, like.
Well, you can change this font down here.
No, I mean like the scale of like.
Well, that's what I'm saying. It auto changed the scale just by us
Yeah, but I mean like.
force it.
So like yeah, like forcing it. So like if we would have still left it at like 10 to 100, like, but we want instead of going by 20s, we wanted it to go by 10s. Like, there's got to be a way that you can still set it to do that and still have the same like the limit you want.
Okay, so we want to look for something called scale. So we're really looking for like the steps. Well, here's like a zoom factor. So this is zooming out on X. Zoom out factor. Change axis scale. Ticks. Set major formatter to ticks. It's just changing the tick labels. I don't know if that really. Change the axis scale. Well, it looks like you can set the individual ticks. So I think we can actually do this here. We can say plt.show, and that should actually show it.
Yeah.
All right, so that makes life better.
Yep.
All right, now.
Will we go to the next question?
Let me do this. Let me do this tick thing real quick. You guys open up this can of worms. Okay. So we're getting subplots.
That's just a joke. People thinks that gives you one karma.
No, I know this bottom part is. This range. I think the short answer is yes, you can, but you might have to go as granular as actually picking your specific ticks. Yeah. So you either have to let them select it for you, or you have to take total control for it. But it seems like we were able to kind of massage it into position by just closing the gap of what we were visualizing. So we saw that nothing was below 60. So by setting the range 60 to 100, it went ahead and gave us a more granular view of this. So this looks like a pretty reasonable way of looking at the data, doesn't it?
Mm-hmm.
I still think the other direction probably looked a little cleaner when we had the X and Y. And we'll change the Y ticks. Actually, we probably don't even need. Yeah. But we'll keep that in there in case we need it at another point in time, but we'll change the X lim to 60 to 100. Oh, I still have my chart open from before. That looks pretty reasonable, doesn't it?
Mm-hmm.
All right, so we're going to call that the winner?
Yeah.
All right, good. So let's look at the next one. Display an appropriate visualization for the lowest 5 calorie cereals. So something pretty similar to what we did here, right? So it is only dealing with 5, but we're doing it on calories. And to remember what the, here, let me just do this. Is it CAL? Is that the column for calorie?
Just calories.
Oh, it's calories, all the word,
Calorie.
the whole word? Okay. So we'll keep the pastel thing. Our ratings, we're going to sort on values, calories, and we're going to say, like actually, it doesn't matter if we say ascending is false or not. It just depends on whether we want head or tail.
Yeah.
So ascending is going, so we want the smallest calories. What did I say? So if I leave it as if I leave it like this, I'll need tail.
Yeah.
All right, so I'll leave it like that. And then we'll say, well, here, we'll call this guy Cals. Call this Cals to display is tail from Cals.
Would you say tail 5?
I think tail by default is 5.
Oh yeah, it does.
Yeah. I don't think tail 5 would break it,
Yeah.
but that is the default. And then we're going to do this. So calories and name. And our data is going to be called Cals to display. Cereal calories. And I have no idea what the range is going to be, so I'm not going to do any guessing at that point. So I'll just do whatever Command S does. Then
Seriously, with the brand? Seriously?
it's,
Is that why it's the highest rating?
it's
The
a-
calories are also low?
it's a barn burner.
This is boring.
Well, no, it's not the lowest though.
One of the lowest.
Oh, it is, yeah. Well, maybe they're tied. 49. They all look the same.
50.
We're
They're all
sure that's
50.
right because when I did the sort for me, like the lowest calories were 100, but maybe I just did it wrong.
I think this should be right.
I feel like it took all the oh wait, never mind. No. That's 5 from the top 7 and in the last one. It's almost like it just took 5 out of the 7 and put them in my chart.
So we're reading it all in. We're sorting on calories on the entire thing. Calories to display is the tail of that. And here, if we choose tail 8, for example, that should just give us more things in our...
Strawberry fruit wheats. Seriously, with the brand in the wheat.
Now, we could flip this around and look at highest calorie, right? So if we close this,
For some reason, when I sorted on calories, it did not sort correctly then.
so we'll switch that to true, but we'll still look at tail. So this should give us the highest calories now.
Not too much.
Muslix?
What
Muslix?
is that?
The crispy blend? Well, I got muesli. Muesli is a, that must, so I get muesli on the cruise ships. It's like a cereal that they've had in like the milk so it gets like all soft. So it's like a, I don't know,
What?
yeah.
Where they come.
It's already like mixed. It's, the cruise ships calls it muesli, and
How is it not just like.
it is cereal, but it's like they made the bowl of cereal with, I don't know, whatever, just weird stuff in it, little apple slivers. It was really good. But it's like they made it a half hour ago, and it's just been turning into like soft mush.
I imagine like a packaged thing where it was just like grain cereal with milk already in it.
Oh, yeah, no. And this is supposed to be that way. I've been on various cruise lines, and they all do it the same way. So it must be some common European thing that like you would find in every European restaurant or something, and it just seems weird to us.
Can you go back to the code?
No. There.
So,
Can I make this bigger? No.
for the... I'm just really confused on what I'm getting. I mean, I used iLock, so I don't know if that would have made a difference. Like, because I sorted calories, like, with sort values, like you did. But I did it where it was ascending, so I was getting the lowest at the top. And then I did, the, first 5 with iLock. But for some reason, it gave me, like all 5 cereals it gave me all had 100 calories, so I don't know.
Well, iLock says give me some rows. It doesn't really have anything to do with sorting, though.
So to be looking at the index?
So iLock, you could do 2 different things. You can say give me the location between some columns, or you can give me location between certain, like columns 1 to 4, or columns, column name, comma, column, another column name, so on and so forth. If we look back at the slides here. So Loc takes a range of rows and lists of columns to return as a data frame.
I did iLoc.
Okay. Takes a range of rows and a range of columns to return as a data frame. So
Yeah, so
this
I
guy doesn't take in names. He takes in like 0 to...
Yeah, so I did it where it was just rows. So I did 0 to 5 because I still had the like categorical stuff in there, which was technically the first one. And so technically it was really only taking 1 to
But was this after you sorted it?
yeah.
Oh, okay. So
And it's
yeah, so iLoc should have, if you did the first 5 with iLoc, 0 to 4 or
Yeah.
1 to 5, I don't know which one it would be.
yeah.
That should be the same as head, I think, if it's post sorting.
Yeah, but like for some reason it gave me Mapo grape nuts flakes, frosted mini wheats, double checks, and crispy wheat and raisins, and all those had 100 calories. So that means it didn't sort properly. So I don't know, like, but from when I did sort values, like I don't have it with the by equals and then like in the brackets.
Okay.
Like I have it where it's just the word, like.
Well, I'm guessing maybe your sort's not working like you thought it was.
That's like how I looked up online and said it.
Well, update your sort to work like this and then try it. See if you get different values.
What arrow are you getting?
She's not getting an error, she's just getting different results.
I just noticed that it technically gave me the.
And everything's 100 calories or something. So either her sort's not working or her sort is working differently than she expected it to work. And she just happens to be getting a collection of 100 calorie things. While you're doing that, I'm going to peek at the next thing. Okay, so we would call this is an appropriate visualization of the lowest 5 calories. Seems reasonable. All right,
Yeah,
and
same thing. The only thing I don't have is the ascending equals false, like so like that line right
but you
there.
get the identical output
yeah.
that you had before.
So it's that output right there, and that's what I had. Well, it's way up there, but that's what I had received before too.
I'm looking at your code. That's sort on ratings. Oh, you're doing 2 separate sorts, but you're storing them in different variables, right?
Mm-hmm.
Why are you not taking the picture from that screen coming from?
Oh my god, let me see it. Good idea. But I can't see very far. That's a good idea.
By calories.
The screen so close.
I know. And I'm like suffering with
I
it.
also cannot see that very clear. I have to use
Because my
the
rating
side
one
screen.
sorted fine.
Hmm.
That's why I like.
Yeah, try commenting out your rating one, the sort for your rating one, just in case the sorts have like an impact on each other.
Even though it's like on different variables.
I would agree that what you've done makes some sense,
Yeah.
but you're getting a behavior that I wouldn't have expected. I can only see your code so well from the 3 feet, but we can look at it closer. But I mean, at a glance, the code looks reasonable. I mean, you might throw in the ascending equals true thing just in case, but okay. So the last one here is dealing with displaying an appropriate visualization comparing fat versus calories for all cereals. Okay, so now we're asking a weird question, right? We have no idea if fat and calories have anything to do with each other, but at this point, we have some data and we're saying, okay, I visualized a couple of things. I kind of know which one is the highest rated, and I happen to know which one is the lowest calories, and those are meaningful things, when you have a whole collection of cereals to choose from, right? But now we're saying, okay, well, I wonder if there's some correlation between some different things in my value. So we can start thinking about connections now. So if I want to look at this kind of data where I want to visualize the fat in my cereals versus calories versus calories in my cereals, what's going to be the best way to visualize that? What kind of visualization makes sense? Don't say a list.
It's colored plot.
Okay, scatter plot? Yeah, so something is going to give me all those dots, similar to what we looked at last time with the coaches, the sports coaches, basketball coaches, whatever, football coaches, I think, right? NCAA football coaches, pay versus rank, something like that, and see if we start seeing some sort of patterns pop up. With no real prediction. I mean, before you did this, how many of you guessed that there was going to be a correlation?
I thought there would be like linear.
Yeah, it seems like high-fat things might also be high-calorie things.
Mm-hmm.
Seems to maybe make some sense. But there's also the counter-argument that, well, maybe the things that make stuff high-calorie might be the sugar.
Yes.
And that isn't necessarily a high-fat item, right? So that would have an alternate effect. The highest calorie ones would be the high-sugar ones, which may not necessarily be the high-fat ones, right? All right, well, so let's go and look at our example for scatter plots. So here's our scatter plots. We'll just go down to our code example here. Let's just creating one. Well, let's see. I think there's a shortcut command in Atom to comment everything. Anybody know what that is?
I don't know.
If I want to see just a column of data, would it be just dot COL and then the name of the column?
I think it's in square brackets after the call. I would just look at a code example real quick. Next, it's control/. Oop, Ninja. So control/, there we go. See that? So I just highlighted the lines I want to comment out, and you hit control/. And it does comments in whatever the language you're currently working with is. That way we can keep those lines of code for later, because I haven't done a bunch of this stuff in Python before, so I might as well have them to feed off of, but it's all pretty straightforward, right? All right, so we're still reading in the same thing. We'll go ahead and set our, actually, for those of you who did the hackathon, what was it, 2 years ago, 3 years ago? 2 years ago when we did the machine learning one, the example code I gave you dealt with this exact same set for predicting petal length given, predicting which iris you had based on petal length. So kind of an interesting thing. So we're going to call this cows versus fat for the win. All right, and so we're using Seaborn here to do a plot, and we're doing this off of calories, and we're doing this off of, this is just called fat.
Yeah.
Okay. I don't know what those are, but let's just run this and see what we get. So
Did
this.
you have a blog show?
Oh no, I didn't. Is that a problem?
I just
It's like, look, I'm not showing the plot. Come on. We probably should do this tight layout thing too.
You don't need to have a layout because it's fat versus calories, so there's no big number.
Okay.
But blog show that I did it. Otherwise, where do you?
Yeah. Okay, so there's our calories to fat. Well, the highest fat was a 5.
I think that is 5% of for the.
Oh, it's 5% fat.
Yeah. So because it's very low, so it's hard to tell.
So
Now, one thing that I'm seeing here is we do notice that we have less than 78 or 77 points here, right? What does that mean?
They could be the same.
Some of them have the same dots. Is there a way to get around that? Remember this from the book?
Yeah, there was a double dot.
Yep. So let's go back into the book. If we wanted to really visualize the patterns, actually, hold on. I had the book open in Windows, didn't I? Yeah. See, now we're switching between OSs in real time. Things are gonna get. Well, this was good though, so you could see it in the actual platform. A lot of you were doing this in. All right. So, what am I looking for? Oh. Yeah, these guys. So we can look at a strip plot. Actually, let me do this because I give you a breakdown. We didn't get to these in the slide last time, but I give you a breakdown of these.
Okay, so I think I know what my thing is doing.
What's that?
So it's still doing like where the hundreds are at the top. And I think what it's looking at is like the first number. And since it's a 1, it's thinking that's lower. So it's like it's not looking at like the whole number.
It's not looking at the whole
Right.
number.
So like this is like I just did the columns. So
Mhm.
it's like going 100 to 90. So it's probably going like 1 to 9.
Oh, for the sorting?
Yeah,
But why would that be different?
I don't know. Because like you'd think for the percentages it would have done the same thing then, but it didn't.
Yeah. I'm going to have to look at it closer. All right, so here we have 3 different types of plots. So we have strip plots, jittered strip plots, and swarm plots. So strip plot is a scatter plot where a categorical variable represents an axis. So in this little example we have here, we have petal length versus species. And we start getting some pieces piled up related to it. So points are stacked on top of each other and form a single column or strip. A strip plot is useful in summarizing information about the data set. The strip plot below shows the relationship between iris species and sepal length. So, we're seeing a whole bunch of data points that are very close to each other that might be showing up on top of each other in our scatter plot. Spread out more here so we can kind of see if there is some patterns. All right, let's look at the next one. So then we have the jittered strip plot. Because even with the strip plot, you might have an issue with things being still right on top of each other, right? So all we've done is spread them out a little bit vertically, but we still might have, we have 78 values, and it seems like a lot of these cereals are kind of in the same ballpark for calories and fat and things like that. I mean, if we go back to our image here, is my image not still open? Whoa, Ninja.
Oh, yes, only open.
So we're definitely looking at less than 78 or 77 values there, right? So we know that we're dealing with some overlap.
So it's like
Yeah. So at the very least, we can say, you know, it's going to make more sense to look at this in another format that explodes out this data a little bit. Not that that's going to necessarily give us tons more information, but it would make sense to do that. Okay. So we look at a jittered strip plot. So kind of the same thing, but what it does is it randomizes the positions so you can see all of the individual values plotted. That's going to help us, right?
Yes.
All right. And then this last thing, a swarm plot. Well, let's look at the difference. So jittered strip plots, data points may overlap when the data set is dense. Data plots may share, and would we say that our current data set is relatively dense? Most of the serials are in the same ballpark of categories, the same calories, and so on and so forth. So it's all the data is within spitting distance, right? Remember last class we kind of talked about the idea of, you know, if you were let's say I was looking at ages in college, you know, you're going to have a really clustered group, right? If you walked into any random person in the cafeteria, the chances of them being between 18 and 22 is high, right? that's you know, maybe if you're walking around campus in the evening, that number goes up a little bit because more of the grad classes are in the evening, but still, you know, that's a very clustered group. All right, so data points may share the same value, or the marks may be too large compared to the plot's resolution. To get a better sense of the data set, a data analyst might use scatter plots. Jittering is the addition of random noise to the plot, so that kind of gets the stuff separated, in order to prevent or minimizing overlap between data points. So we're not guaranteed that we won't have overlap here, but we should get a little bit more of a spread at the very least. Whereas swarm plots, these are jitter plots, do not entirely prevent overlapping. An alternative approach to jittering is to use a swarm plot. A swarm plot uses a random algorithm to set a minimum distance between points. So this guy guarantees that you won't have overlapped data. Now, realistically, if I'm looking at the data like this versus looking at the data like this, these guys basically tell the same story, correct? So you probably, for a relatively small data set, you're probably not going to notice a huge difference between these two. But if you have really large, dense data sets, you're going to start noticing some issues. Make sense? All right. What I'm going to do here is I'm just going to keep going for a bit. We'll finish this up. We'll kind of look ahead at what we're doing next, and we'll finish up around 30-ish. Is that okay? So rather than taking a break now, we'll just go for another 20 minutes and okay. All right, so let's keep going here. So we got some options here. So let's go and let's try one of these and see what kind of visualization we get from it. So we'll go back to the book. Where is my code example? All right, let's just go to a swarm plot. I think that's going to make some sense, right? At the very least, we would say it's not going to give us a worse result than a jitter plot. All right, so the X is going to be on,
I think a fat will be better.
Okay. And then Y will be calories.
Yeah. Because fat only has 6 good categories.
Yeah, and the hue, we're not actually going to have a hue for this. Hue has a meaning. I'm trying to remember what hue was. It's in my notes here.
Not here.
Let me just look it up real quick. I distinctly remember that is in the book, hue. Hue is one of the main properties called color appearance parameters of a color defined technically, blah, blah, blah. Defines which column in the data frame should be used for color encoding. Oh. Do we have a reasonable thing to use for hue? I think we could probably just leave it out. Let's leave it out. This guy right here.
Data.
Yep. This is going to be DF. And then I'll comment out this guy.
Also, just to let you know, so I don't forget, I just noticed on YouTube you posted something for, well, it says CSC548, but it was actually,
It was the wrong thing.
it was like from 10 a.m., class 10 a.m. this morning, so I don't know what that is, but.
Okay, thank you. I'll fix that. Okay. So we get, I mean, I'm not counting them here, but it looks like we have 78 probably. All right, so if we're looking at calories, we see that we have a whole lot of things in like the 110 calorie range. We don't have very many things in the 160 calorie range. So can we draw any conclusions off of this? We were looking at calorie versus fat. None of the things are, I'm guessing these are grams of fat. Are you sure they're percent?
Maybe gram, but I don't
Yeah,
know.
usually on packaging, it's fat in grams for cereal, and cereal isn't necessarily a high fat food typically, so I'm guessing this is grams. So if we look across the chart here, the lowest calorie cereals tend to also be low in fat, correct? So here's 3 cereals that are very low in calorie that also are very low in fat. That's a reasonable connection we can make. Similarly, if we look at our highest calorie cereal, you know, here this is a higher calorie cereal, this is a higher calorie cereal. We'll call this a higher calorie cereal. They're kind of in the middle of the pack when it comes to fats, and maybe we call these more balanced, something like that. I don't know if we can draw strong conclusions from this, but we see this guy as somewhat of an outlier. So the highest fat food here, highest fat cereal, is actually kind of in the middle for calories, isn't it? So maybe that's a little bit interesting, but it certainly seems like the lowest calorie cereals are also very low in fat. That seems to be a reasonable conclusion we can make off of this. I mean, especially you look at these 3, there's 0 other, let's call it sub 70 calorie cereals here that have any fat. And if we just extend that just a little bit, you know, we look at the 80 calories and less, those are all low fat. The most you have is 1 gram of fat. Once you get above 80 calories, actually all the way up to, let's just call this 90, all the way up to 90 calories, you have these being, we'll call 0 and 1 relatively low fat. Fair enough. So really, 90 calories and below, the fat is always low. Once we get to 100 calories, it starts spreading out a little bit more. At 110 calories, it spreads out even a little bit more. At 120 calories, now we're just across the board, right? Okay, so, you know, we can make a conclusion here that relatively low calorie cereals also are relatively low in fat. How meaningful that is to our daily lives is, you know, we can decide, but it was an interesting question we could ask about our data, and we were able to give ourselves some sort of answer that may or may not be life-changing. Okay, so was that all the questions on the homework?
Why do you guys need to fix the
Yeah. So earlier we went into our CSV and we removed that second line in here.
Okay.
Yeah, so we used to have a line in here that looked like that. So these guys are filled up with non-numeric stuff.
Okay.
So this guy told us the data types we had, but I just went into our CSV and
Okay.
got rid of that line.
Okay.
Now we only have numerics.
Okay, thank you.
Yep. I think there's probably a way to do it from pandas too, to say ignore row 1 or row 0, whatever it's called, because it's probably somewhat common that stuff's in there.
So, okay, but, so like when I got that numeric error though, I was getting it on my, like, cut down data frame. So like my 5 pieces of data, which those would have just been numeric. Cause
Not necessarily, because weren't they still giving us that top thing?
No.
Well, here, so let's see if I can give myself the error. Okay, so, yeah, so this is the error right here, right? I just created the error by putting that line back in. All right, so let's look at an alternative way of getting past this, as if I'm not going to destroy my my CSV. So let's just look at pandas, ignore row. Let's see. Skip rows.
Because those were actually the data type, right? Yeah, it was there.
So I'm going to skip row 1. Yeah, I think that's just it. Skip rows equals 1. So this is when I'm reading it in. Skip rows 1. Okay, so by skipping that, it looks like I skipped the wrong row, so I need to skip 2. So it looks like I got rid of my headers. Nope. That doesn't seem to be. So actually, yeah, we probably do want to read in the whole thing. So at this point, I'm trying to skip it at the read in point. But if I do that, then I start losing stuff. So I want to do it post reading things in. Here, dropping rows and columns in a data frame.
Yeah, that's literally the exact same documentation I was looking at last night, and it didn't work. At least what I tried didn't work.
Yeah, so it should be, we'll drop index 0. This should fix it. So this got rid of the first real line, because when this thing reads it in with those headers. So that's not part of the output. Yeah, I think this fixes it. Okay, X or Y does not appear to be numeric.
And if you print df, like, just to see if it's still there, because when I did that, it was still there.
I see. So print df.head, like that. Okay. So then let's remove index 1.
Can you actually drop,
Actually, it's
the
showing.
type?
It's showing 0 here. Hold on. Hold on. All right, so dropping that didn't actually drop anything. Oh, you know what I bet? I bet you have to do this. df is equal to df.drop. Yep.
That's so stupid.
Yeah, so df.drop does not change the data frame. It returns a data frame with row 0 dropped.
Yeah, I had a hard time in homework to realize that.
Data
You
frame
actually
never
change.
change. It's only
Yeah,
Where's
only
my...
given you one.
I answer, yeah, I took me a while to
This
see that
is-
was not changing my stuff.
All right, so that's an alternative way of doing it without destroying your data. Or changing your data. That way you still have access to those data types if they're meaningful.
Yeah, I mean, I completely took out the line and just tried it again, like running the plot, and I still got that error though. So I don't know, but my code might just be messed up because
Okay. All right, so questions on any of that? So we kind of got to explore our different graph types. We learned about path, and this is not a Python thing. Path is a how operating systems work thing. You know, when you install a program on a computer and you want to go and run it from the command line, it better be somewhere in your path because that's where your OS is going to look for it when it starts determining, does this person know what they're trying to type or not? You know, so if I go out here to DOS and I bang on the keyboard, let me close this. Okay, so I come out here and I bang on the keyboard a bunch and I press enter. It's not going to immediately tell me it doesn't know that. It's going to say, well, let me check this place. Nope, nothing made up there. Nothing made up here. Nothing made up here. And finally, it's going to come back and say, that's not recognizable. I looked all over. I looked at all the places your path variable told me to look. Didn't find it. Make sense? All right. And then every now and then when you do add something to your path, sometimes you need to quit the command line and then go back into the command line to get it to reset. If you're on a Mac or you're on a Unix machine, you can actually type in the word source followed by like, I think for Mac it used to be .bash RC or bash profile, but I think now it is Z. It's a Z shell.
Yeah.
ZSH profile, ZSH whatever. But that's where your path variable is stored on a Mac. So if I just show you this real quick, if I go over here to my Mac side, and I just go to my home directory and I do ls-a, actually let me do this, ls .star. So here's bash profile. And I'll just do more on that. So notice here, this is a Unix-based system, and this is the path, export path equals, we're gonna look in op local bin, op local sbin, and then whatever path used to be called, used to be equal to. Notice that it's changing up here as well. So this is the Python framework stuff for my path in Unix. So it's still called the path environment variable. It's just handled by this local resource file as opposed to in Windows. Windows has an environment file. I don't even know what it's called anymore, but I showed you how to get to it. But you can also update it from the command line. I think just using export will make updates to it. All right, but this is not something that is related to Mac or Windows or something specific. Path variables are global variables associated with operating systems. So last thing, let's just kind of flip through the last couple of slides here. So we've now explored swarm plots. A line chart maybe would have made some sense. Would have made some sense in any of our stuff here. Not any of the questions we asked, but we probably can come up with some interesting questions where we can plot some stuff out in a line chart related to our cereals. Linear trend lines allows us, so I mean, we're looking at kind of Apple stock here, for example, and they're showing, you know, over a period of time, what does Apple stock look like? And if we're staring at this, we're seeing all these different points in time. And now a human being can look at that and kind of sort of, you know, see that downward 20-degree trend, something like that, right? But you know, you can have a trend line drawn in there for you, which actually shows you that slope, so you can kind of more easily visualize that that trend. This is especially beneficial when you have a lot of zigzagging, things like that. Having multiple lines in a thing to kind of see how things are changing. So this is dealing with temperatures in different places. As you might expect, there's some places in the world where the temperature is always going to be hot. So the question is it hot or is it really hot? And then you're going to have a place like Wisconsin where we're going to have this bell-shaped thing where it gets very cold here and it gets reasonably warm. I don't know about very warm, but we've had our 100+ days before. But we cover the gambit, right? You know, in Wisconsin. And then you have everything in between. So this is kind of an interesting way of, so this is Paraguay, China, and Pueblo, USA. So it looks like in Paraguay, it's a pretty warm climate across the board, right? That's probably similar to Brazil. Yeah, so I mean, it's nice year round, but you got some of your hot months, right?
Oh, yeah.
You don't get snow in, what part of Brazil you're from?
Southeast.
No, so you're not Sao Paulo. Who do I know is from Sao Paulo?
Close to São Paulo.
Okay.
16 hours.
It's not close.
The horse.
That's not close. 16 hours by horse? So did you say 16 hours by horse?
Depends on the horse, right? Depends on the good horse.
So we're back to the Brazilian grandma outside sniffing the dirt. So tomorrow's gonna rain. 16 hours by horse.
But I would say that Paraguay is colder than Brazil. Colder than the area there.
Yeah.
So you're even warmer than that.
Yeah,
So
it's much warmer.
what's the coolest it gets? 80s?
It can get a little lower if it's the middle of the night. Yeah. No, but
38, I would say, the coldest. No?
not where I live, we don't even have water anymore.
I mean, my town is in the mountains, so.
No, mine too.
But yours is.
That's why you have horses?
Mine's
The
not.
cars can't make it up in the mountains, you need the horses?
Oh yeah. you think I'm kidding you?
No, but you are in the valley. You are between mountains, so your city is hotter than mine. I'm on the top of the mountain.
So then some of the other things we talked about is, you know, and we saw some examples today, poor use of charts, right? Using the wrong chart for the wrong thing or even the wrong orientation for the wrong thing. Okay, so just looking ahead here. So one thing that you might have noticed is, I'll go back in here because that's where my Xi book is open, is we are going to run out of weeks before we run out of chapters. But if you actually peeked into some of the chapters, we are going to be doing some weeks are going to have multiple chapters in them. So for this week, you were to have read chapter 10, right? And do the book homework for chapter 10. All right, so this gave you some things dealing with surveying and box plots and histograms, right? So I'm going to give you a homework assignment that's going to relate to that stuff specifically. Now, next week, we're going to read just chapter 11. So you start noticing that chapter 11 is, you know, a normal, has plenty of stuff in it chapter. So that'll be a single week thing. But as we start getting down a little farther, so 12 will be by itself. Linear regression, 13, this will be by itself. But now we get farther, where does it start shortening? Okay, so like 14 and 15 will probably be together. And then 16 and 17 will probably be together. You see, these are a little bit shorter chapters.
Yeah.
Okay, and I think that should put us right there at the right end point. So I think Jordan had asked, like, hey, we have less weeks than we have chapters, but you see those last couple are compressed chapters. All right, so I'll get the homework up probably before noon tomorrow. I'll find a reasonable data set that allows us to ask some interesting questions, and it'll be related to what we looked at in chapter 11. But does everybody feel a little bit better about where their Python install is and stuff now?
Yeah.
We're
Mine is working.
okay. So we're good. And was this helpful doing it in Windows? Do you want me to do that again next week, or do you want me to do the Mac side again, or what do you want me to do? We like Windows?
Yeah.
Okay, that's right. Doesn't matter to me. Okay. Questions, comments, concerns, bribes. Oh, by the way, everybody before had seen my my Stargate. I had an 8-inch Stargate, and we have a new printer we just got in today that can do a 20-inch print. So down in our makerspace, I used to have a Stargate that was this big. Now I'm printing a Stargate that's this big. And it's going to take like a day and a half. It's going to be awesome.
Oh.
So it's down there cooking right now. If you happen to be going out by the business building, you can go check out the...
Imagine if he's gonna be all night changing the...
We actually might run out of filament.
Yeah, we have to check now, otherwise.
All right.